Hello, everyone. Welcome to OpenCV Live. I'm the CEO of OpenCV.org, Dr. Satya Malik. And today we have a very fun episode with Katherine Scott. She is a robotics industry stalwart, and she'll give us a guided tour of the coolest announcements at ROSCon and other events by ROS. So Kat, always shows us amazing stuff on this on our podcast on our show, and this episode is not going to be any different. But first, as always, with us is Phil Nelson. He's the Director of Content and Creative at OpenCV. He produces this show. If anything goes wrong, it's his fault. Hi, Phil.
Yes, good morning out there, everyone. You heard right. It's Thursday morning, and you know what that means. It's me. It's PHILLIP. I am your co-host with the co-most, the second banana who is second to none. I'm also your plus one and only. It's Mr. Nelson if you're nasty, but you, my dear friends here on OpenCV Live, can call me Phil, and I'm here to remind you of a few things we do on every single episode of this here program, which you're currently watching. The first of which is a giveaway to you in the audience. Stay tuned. Later on in the episode, we will be asking a trivia question based on the presentation from our illustrious guest, Katherine Scott. And the first person to answer that question in the Zoom chat here, which you can get to by going to opencv.live in your web browser, will win the OpenCV course of their choosing. You can find out what courses are available by going to opencv.org/university. Bunches of awesome stuff on OpenCVU. The reviews are in for all of these courses, and people really do seem to get a lot out of them. So go check those out, even if you don't win today. We're also taking questions from you in the audience, and we will do our best to answer them, as the late, great Satoru Iwata would have said, directly. So please answer your question in the Q&A button here on Zoom, and we'll do our best to answer them during the show. If you're watching anywhere else, just post it in the chat. I will be monitoring those, and we'll try to pull out the best ones to ask during the program here. If you ask a question and it doesn't get answered during the show, feel free to send us an email, newsletter@opencv.org. We are easy to find. Before we get started, Doc, let's talk a little bit about, we got some news here. I want to give a quick shout out and thanks. I'm going to share my screen. We'll do about three minutes of patter here. We've got some big news from our buddies at RoboFlow. RoboFlow just announced their raise. They just raised another 40 million Series B round. Huge shout out to our buddy Joseph Nelson and co-founder Brad Dwyer. Of course, Joseph, super well known to people on this show. He's been on the most episodes of anyone. I think, Kat, you're actually in second place there. Yeah, check out. They have some great coverage in Fortune today. You can go find this link. I'll drop it in the chat systems here as well. RoboFlow is a great company, great OpenCV supporters, great supporters of open source in general, and it's really great to see some of the companies out there that I know are being run by some pretty moral people overall, getting some of that VC cash. So shout out to RoboFlow. Well done out there, folks, and well deserved, I think. Thoughts on that, Satya?
Yeah, I mean, I'm always very happy when good things happen to good people. And Joseph and his team, they have been really executing so well, not just for RoboFlow, but for the community in general. They produce a lot of content that is computer vision related content that is very, very useful for people in general, not just the RoboFlow audience. So I'm really, really excited about them raising this money. They use it very well.
Absolutely. Could not agree more. And stay tuned. We've got some pretty cool stuff coming up with RoboFlow soon. So also, OpenCV is a nonprofit organization that runs an open source computer vision library, and we absolutely couldn't do it without our members and partners. Thanks so much to all of the current OpenCV members and partners out there. Here's give you your 15 seconds of fame here at the beginning of the show. Also, if you are someone that uses OpenCV in your work, you can donate individually. You can go to opencv.org/donate, give us a couple bucks if you got it, or advocate to your boss or your boss's boss for your company to become an OpenCV member yourselves. It starts at just $6,000 a year. All that money goes into creating the open source computer vision library that you all know and love, and as well as doing shows like this. You can also sponsor OpenCV on GitHub. We've currently got 7 sponsors out there. Thanks so much to all 7 of you. There's also an OpenCV merchandise store. You can go to opencv.myspreadshop.com. 15% off everything right now. So, hey, improve your wardrobe. Some of those t-shirts you got are looking a little bit ratty. I'm just saying, as a friend, maybe you should buy one of these OpenCV shirts. Having said that, Doc, I think that's enough from me. Let's get started, eh?
Well, welcome, Kat, and I'm very excited to see all the things that you have to share. Please, it's your show. Take it from here.
Oh, okay. Well, let me fire up. I brought slides because it just keeps us on track and reminds me. I got a lot of talks to talk about, so I got to remember which
Yeah.
is which.
You can start with a short introduction.
Well, yeah, why don't we do that? So I'm Kat. I'm the developer advocate over at Open Robotics. So we build, our bread and butter is Robot Operating System, or ROS. So that's the big one. We also do Gazebo, which is our robot simulator, and OpenRMF, which is our sort of multi-fleet robot control software. So if you're on any of the ROS forums, like ROS Discourse or our Discord, you'll probably run into me because I'm the person keeping all that running and writing weekly news updates and managing community stuff, and maybe even sometimes getting to merge a pull request or two. And I'm one of the organizers of ROSCon, so you get the inside baseball on ROSCon.
Yeah, those pull requests are like a treat.
Right.
No, I'm always like, it's a good day because I get to do a pull request today, or two, maybe sometimes even three. All right, so why don't we fire
Wow,
this
must be
up?
Christmas.
All right, got that. You can see it, Bill?
Everything looks great.
All right, so let's start off. So ROSCon this year was in Odense, Denmark, which is a fairly, it's about 250,000 people. It's about an hour train ride west of Copenhagen. I put it on a map there because I don't think most people actually know where Odense is. It was about, so what is today, 21st? So it was about a month ago today. I got back about 2 weeks ago. We just got some of the videos up. So the thing to know about Odense is you're like, why would you have a giant robotics conference in this little tiny town out on this island in Denmark? And the answer is this little tiny, not little tiny, but this little city in the middle of Denmark has done the thing that like all of the other cities in the Midwest or like in the rural parts of different areas wants to do. And that is they've basically built an industry around that town. So you think, oh, Odense, 250,000 people, how many robotics companies could there be there? Two. One. Turns out there's actually, according to the Odense website, there's about 340 different robotics companies in Odense. The big one is Teradyne, which is a large contractor. They also sort of have acquired Universal Robotics, have acquired Mir, which is mobile indoor robots or mobile industrial robots. But within the city, there's a huge audience of robotics developers. Everything from like 1-2 person kind of consulting companies to these giant orgs. I remember I was at Automatica maybe a couple of years in Munich, and I ended up running into this company that just built this end effector, and all it does is it's just really good at doing putting in screws and bolts. That's all it is. They just build this one, $20,000 end effector for a robot that just does screws and bolts, and it's like a 5-man team outside of Odense. So some quick stats. We sold out like 2 weeks, 3 weeks before the conference even happened. So we decapped at about 975 people at the conference. I'm sure we could have done a lot more if we had a lot more space. When you end up looking at all the email addresses, there were over 550 different organizations at ROSCon. So, companies, universities, individuals, and that's an increase of 25% over last year. We probably could have done more. 42 sponsors. We ended up having the community put together 17 different birds of a feather sessions, did 8 different workshops. I ended up running one of them. We had 16 diversity scholars from all over the world. So we had students from Iran and Nigeria and India and just all over the globe. We have a diversity scholars dinner, which was amazing to attend. If this is something you're interested in and like to attend ROSCon next year, the call for diversity scholars comes out really early, sometime like March or April, because we have to give people enough time to apply for visas. So if you want to come to ROSCon, probably can't afford it, this is an option for you. yeah, and overall, 50 different countries were there, at least 50 countries, over 70 universities. It was just a wild set of people. I got a quick video. Oh, it's autoplay.
We can't hear the sound.
No audio, but it's just music anyway. It'd probably get us a copyright strike. So don't play the audio.
A little loud on my side.
It's probably just not shared on Zoom, but again, that is for the best. Here, I'll just hum a little tune.
Okay.
Is that good?
Yeah, excellent.
I tried to capture the gravitas.
The sense of it, yeah. I mean, that's the quick video.
I really like that video.
There's a long one with a bunch of interviews. So that just gives you a sense of it. So that we weren't actually DMCA sounds. Yes.
One question I had, the diversity scholars, these are students that you sponsor, or anybody can apply?
Well, anyone can apply, right? But they're students that we cover airfare, hotel, the whole conference, right?
Got it.
And there's also volunteer opportunities too that are, there's sort of a gradient of things we can do to help get students to the conference. And that's one of the things that the OSRA is super excited to be able to do more of now. This gives you a little bit of a scale of what we're talking about. It's, the facility we're at was really interesting. I wouldn't call it necessarily a conference center, because normally, you go down to the conference center in San Jose or a big conference center, and it's, your standard sort of conference center with breakout rooms. This was actually the biggest theater in Odense, where they do all their plays and musical performances, and we sold it out. So you walk in. What you don't see here is the second level. There's a whole second level above here with also people, but this is what you walk out to when you're presenting at ROSCon. And it was kind of terrifying. We've gone from a room of ROSCon. I spoke at ROSCon 2015, right? And it's a room of 200 people, and now we're here where it's like you walk into a room and it's 1,000 people. Just some candid shots of what was going around in the exhibitors area. There were all sorts of robots. We have the big robot from Dextery. So this robot extends. You can't really see it, but it'll actually extend fully to about 40, maybe 50 feet tall. So like 10, 12, 13 meters tall. And the whole purpose of this is the robot on the left. The whole purpose of that robot is basically to go and scan store shelves. So it can extend up to these giant shelf units. Runs ROS. We had our colleagues over from PAL Robotics. So they are the OG humanoid people. I mean, there's a ton of humanoid robotics companies, but PAL has been doing it here for at least a decade, probably longer. They actually help define the set of ROS messages that are used for HRI and ROS. Really, really interesting team. They have a bunch of different humanoids for a bunch of different applications. Tons of mobile robots. We had Unitree there with all the Unitree robots running around. This year we actually, because of the way the facility was shaped, we were able to have just a nice safe robot demo area that was running during most of the conference. And then for a lot of the exhibitors, we just kind of placed them around the building. So it wasn't like there's an exhibition hall and talks and then, an area where you got lunch. It was all sort of mixed together. It was actually kind of a cool facility. Before I talk about the talks, I just want to preface this by saying all of the talks are up online. They're free. They're free due to the generous support of our sponsor, AMD. They are not on YouTube. They are on Vimeo. And we've been using Vimeo as our video archive for close to a decade now. What's great, I know it's a pain. It makes it difficult to search for, but also if you don't pay YouTube every month and don't like watching 20 minutes of ads for a 20-minute video, they are all ad-free and just play and are easy to distribute. And you can find them all on roscon.ros.org. You just look at the schedule. All the videos are there. And then also almost all the slides from all the talks are there. And then usually if the author is talking about an open source package, the source code's there too. So it's really kind of your one-stop shop for everything ROSCon related. So the first thing I want to talk about is I spent the first day of ROSCon the first day of ROSCon is usually workshops, right? So we had 8 workshops this year. They all sold out basically immediately. I ran one that was an intro to ROS workshop. So basically we did an hour here, an hour there, talking about each of the different projects and how they're used. And then I did about 4 hours of hands-on ROS education. And then we kind of wrapped it up talking about like how you start an open source robotics business, or just a robotics business based on ROS. What's cool here is that with the TurtleBot, we've put together a full Docker container, and I've stripped that Docker container down to the point where the simulation and the robot, I can run it on my 10-year-old personal laptop without any problems. It's not blazingly fast, but it's fast enough to do the job. And, to do that, we had to turn off a few things, like the LiDAR isn't running in the simulation and a few other things. But it's a really nice little self-contained Docker container where you can go in. You basically have the software and hardware, simulated hardware equivalent of a TurtleBot 4, and you can go in and learn ROS, go build your first ROS node, explore how the TurtleBot's put together. So, you can go in there and use your ROS CLI commands to see like, oh, there's this node doing navigation, there's this node doing like control, there's this node running the UI of the robot, and you can actually pick it all apart, get familiar with everything, and learn how to do it. Everything from this workshop, the workshop itself wasn't recorded, but all the materials are free and open source out there. So if you just go to this URL, it'll actually walk you through the whole process, and it'll teach you some really basic ROS CLI commands and basically ROS Python development through the first intro sort of topics, all in the simulator. Another relevant workshop that we had, like 3 or 4 relevant workshops that I think are relevant to the OpenCV community. We also had one on demystifying ROS networking. So when we moved over to ROS 2, it used to be that ROS 1 just had this built-in networking stack underneath of it, right? So it would, we kind of rolled our own using TCP and UDP network stack that would move all the messages for you and do everything. And we kind of made trade-off decisions such that it made it really easy to use, but it wasn't always, say, performant if you wanted to, say, have some types of hardware architectures, right? So in ROS 2, what we did is we replaced that with an abstraction layer, and we let people choose what sort of network connectivity they want. Initially, that was a technology called DDS, or Data Distribution Service, but it's opened up to also a couple other protocols at this point. There's one called Xeno, which is basically Rust in, I believe, primarily UDP. That's supposedly easier to use by some accounts. And then there's also things like Isor, which is just in memory. And I actually have a talk about that later. But this whole workshop is about demystifying like ROS networking. So if you want to do something interesting, like in your home, I want to have my home network, and I want to have 6 different robots on it, and I want to figure out how to make sure all those robots are networked together such that they can talk and interact, or they can network with a base station, or I want to have, something in my firewall such that these robots can go talk to something on the other side of the internet. This is the workshop that you want to look at. The best thing, I was poking around on the materials for this workshop, and inside of it, there is this ginormous flow chart of debugging network problems in ROS. It is like the most useful resource I think I could ever point people to, because a lot of times people understand the robotic side of things, but I'm not an IT person. Like, I'm not the best network, like I can check what my IP is and like set up my home router, but I like much more than that, kind of like, oh, I'm sitting there on Stack Overflow like everyone else. And so this like flow chart is really phenomenal for figuring out like,
Right.
what's where, how to debug everything. I know
networking in general, like any kind of communications between stuff, is still like one of the biggest pains for any of this kind of tech. Like just picking which way to do it is enough of a problem. Like it could be Bluetooth, Wi-Fi. They got those little busy bee thingies. There's all sorts of different ways to do it, and then you have to actually implement it. It's a lot.
Yeah, it's not exciting. And the thing is, like, if you're a roboticist or a computer vision person, like you're like, I know enough to be dangerous, but this is definitely not my strong suit. And so like stuff like this ends up being like the worst part of your day, where you're like, I got to get something done, but like this is kind of at the bound of my knowledge, or I don't do this every day. I barely know the tools that'll help me through it. And while it's maybe not like super sexy computer vision work, it's like, oh my God, this makes my life so much easier. And I think that's a lot of what ROSCon is about. It's not always like the latest, greatest research. It's like, these are the things that people are actually using to get the job done all the time. Then I have one more. This one was really cool. So so this is, I'm gonna check his name here. So this was a team, I think it's out of the university or the, what is it? The Polish National Research Institute. Let me find it here. Yeah. So it's the Polish Academy of Sciences and then one of our consulting colleagues. So this is Janis Binkowski. And what he's done is he's basically made this open hardware LiDAR device. So it's basically this like LiDAR, like 360 LiDAR on a stick. And so when you're doing robotics work, right? So a lot of times, like to do autonomous navigation indoors or outdoors, the first thing you do is you go through with like a LiDAR and you build a huge map, right? So like most Waymo, like for example, like a Waymo car or a self-driving car doesn't go into areas where they haven't been before, right? Most of the time, the reason they've been driving around San Francisco for 10 years is that they've been mapping the city with these LiDARs for 10 years, building up this high definition map where they can, you're like, okay, I'm going down this street. Let me double check that I'm actually on this street and I can actually figure out where I am, do all the slam and positioning stuff such that I know where I am down to like a couple centimeters. So what's cool about this is like, say you want to do that for like a college campus or like your work campus or around your neighborhood. Basically what this guy's done is he's built this handheld module that you can go take out and grab all these meetings or grab all this data, come back home, import all of that LiDAR data in one place, basically do the ICP to line it all up, do the EEE, get it all lined up so you can build your 3D models, and then use that, to deploy your robots later on. And so this is all open source software, open source hardware, fairly useful tool, I think, in the world of robotics. If you want to go out and map an area and your robot, sending a robot out without a map could potentially be a dangerous or difficult proposition. So this just allows you to go in and manually do it and then send the robot out. Oh, thanks for the link.
Yeah, very cool.
So let's move on to the actual talks. Those were just the workshops. Keynote this year was pretty cool. It was from a colleague of mine, Deanna Hood. She used to work at Open Robotics, and she was talking about the startup she works at, Vexiv, and what they're doing. Some of she was a little cagey about a few things because it's a startup, and I think some of the stuff is proprietary as they sort of patent it and figure out how their IP is going to work. But my understanding of the problem, and don't quote me here, I'm paraphrasing, is that like when you do like kidney dialysis, right? Your kidneys stop working and you need to like plug into this machine that cleans your blood. To do kidney dialysis, they need a really great map of where all the big veins and arteries are in your arm to go hook up these giant tubes that like suck out all the blood, clean it, and put it back for you. And like getting this done, like figuring out where all these ports and stuff go is a huge rate limiting step in getting people into treatment for kidney problems. And so what they've been doing is they've been building this crazy robot where you shove your arm in it. And like, as far as I could tell, what I think's going on is they kind of have these like waterbed plastic bladders that kind of come down around your whole arm. So, you'd have like two plates, you stick your arm in there, and the two plates come down with like this waterbed thing and kind of wrap all the way around your arm. And then there's like a 2-axis CNC head, like a 3D printer in there with basically an ultrasound head. And so they basically do the CNC thing where they run the ultrasound head through this water bladder on your arm, collect all of the ultrasound data, and basically do like slam on the ultrasound data to do a 3D reconstruction of the veins in your arm so they know where they are so they can put in these ports. It's super cool stuff, right? And like you're like, oh, well, and you're like, is this computer vision stuff? And it totally is.
Yeah, I
Because,
just keep thinking, I must not fear. Fear is the mind killer. Fear is the little death that brings total obliteration. I will face my fear. I will permit it to pass over me and through me. And when it has gone, I will turn the inner eye to see its path. Where the fear has gone, there will be nothing. Only I will remain.
Well, it's not going to insert any needles or anything like that. It's just doing the medical imaging, right? And you can see on that image on the right, there's an image coming from the ultrasound, and then
Extremely
you know,
cool.
then it finds the vessel, right? And so then you have like a slice, and you say, well, the vessel, we think the vessel is X, Y, Z here, and then you do like subsequent slices, and then you have a series of points, and then you go and map that all into like the spline that's going to define where that artery is or that vein is. So it's super cool stuff. Like this is definitely the like kind of problems that I would just love to work on.
Lots of really interesting stuff the last couple of years with these kind of soft robots. You know, they're either bladder based or maybe the material, some new material, right? Like super interesting. Like, yeah.
Well, you know, but what's interesting about this is that like the bladder is just because you need you know, you need a medium for the ultrasound to move through, and I think that, you know, the bladder's there just to keep like a liquid interface such that like it can, like, I think there might be some goo involved when it's scanning your arm too, like, you know, that ultrasound goo. I don't know.
You gotta have some goo. Yeah, gotta have some
so
goo.
they put the goo on, and then like the bladder comes around, but like underneath of it, you're like, so really, this is just like a CNC head, like a 3D or like a 2-axis gantry, like a 3D printer, and then like one of those ultrasound machines, like, you know, if you're having a baby or whatever, where they go in, you're like, you could probably, I bet I want to see the first version of this. Like, I'm pretty sure like somebody just totally bought one of these ultrasound machines, bought like an old, like large format 3D printer, and like that was the first version of this, and like got it good enough to work. Yeah, super exciting. I love this kind of stuff.
Awesome.
Let's see. So we changed things up at ROSCon a little bit this year. So this is Chris. This is the ROS2 tech lead. So now what we're doing every year is we're having all the project leaders for you know, ROS, Gazebo, OpenRMF, and the ROS infrastructure come up every year and just do like, here's the state of the project. Here's like, you know, we do a release every year. Here's what was in the release. This is the process that we did to get the release. And then here's the stuff that we're planning for like next year. This has been a big change. I mean, I don't want to say it's a big change for ROSCon, but it's something we're trying to do more, right? We're trying to move more towards like involving community in development, get people involved. And so I wanted to put these up here because, you know, if people are always like, oh, I don't know what's going on with ROS, what's coming up? And it's like, this is kind of your place to hear about, like, you know, what's on the roadmap for next year, what we finished this year, you know, and kind of figure out how you can loop in if you actually want to contribute to the project. So, you know, I wanted to shout these out because I think they're helpful. Like if you watch 4 things, if you just want to understand the state of like the ROS infrastructure, which is i.e. the build farm, Gazebo, and then OpenRMF, this will basically give you an idea of what's happening and what's on the horizon. Let's see. Time of flight for collision avoidance. So this one is interesting, and forgive me if I, you know, I'm paraphrasing all of these. Like some of them I watched online, some of them I watched in person. But this one's really interesting. So it's not like a bunch of high fidelity cameras. So the problem statement here is older robots, like most traditional manufacturing robots, don't have a lot of feedback on them, right? So that's why you put them in a cage and you can't interact with them, right? So if you're on, like, say, an auto assembly line, a lot of times the robots that are, like, say, picking up car parts or car engines or whatever, they don't have any feedback control. They don't know what's around them. So you got to keep that area clear, because like if you put your arm where that robot's going to go, it's just going to go straight through your arm. And you know, this is not good generally if you want to interact with robots. So this was an interesting one talking about using time of flight sensors, where you basically have these little tiny, you can get like a couple, well, it's time of flight. So it's not exactly like a LiDAR, but like, you know, tiny little TOF sensors that are basically measuring the distance from anything coming out directly from the sensor. So what they did, my understanding here is that they basically instrumented like an existing robot arm with a bunch of TOF sensors that they could purchase, purchase it cheaply on like Adafruit or some vendor.
There's a lot more of them than there ever have been before these days.
Yeah, and then they're basically using them to do trajectory replanning, right? So like, the problem you're trying to solve with a lot of modern robotics is I have a surprise thing in my robot's workspace around my robot, and I need to make sure that I don't hit it because it'll break the robot, it'll break the thing, all heck will break loose. It's not a good outcome. And so this is just their approach to basically dropping a bunch of these TOF sensors onto the robot and allowing it to sort of have proprioception about what it's doing and where. And again, you're like, is it computer vision? I don't know. It's a bunch of TOF sensors. Basically, it's like instead of having two big eyes looking down on a scene, why don't we stick a bunch of small, tiny eyes around the like exterior of the robot, which is a different way of breaking up the problem, but might also be a better way of breaking up the problem in some respects.
The giant spider method.
Or what are the like a clam, right? Like a clam's got eyes all the way around the front of it, right? Different animals have different proprioceptive approaches. Lightning talks. So lightning talks are the biggest part of ROSCon, I'm pretty sure. So what we do is like, we've all been there, like you go to a conference and like, oh, the CFP closed like 6 months ago. I forgot about the CFP. I didn't submit a talk, but I have something cool that I want to share to everyone. And so like, why don't we just give everyone like 92 minutes to basically do their pitch about what they've been working on instead of having this like big convoluted CFP process where you have to, write your talk 6 months ahead of time and then give a 20-minute talk. Let's just do a bunch of tiny 2-minute talks and then everyone pitch what's going on. So I didn't go one by one through all the lightning talks. If you're like, one of the big things that I think you should look at ROSCon is just go watch one of the 2 lightning talk sessions. It's basically about, each of them are about 45 minutes to an hour. And so in an hour with 2-minute talks, you can get 30 talks in. And there's just so much content there. Basically the way we suggest people do it is like, 4 slides, here's who I am, here's what I'm doing, like, here's why it's important, and like, here's how to find out more. And it's just like super right. It's like TikTok before TikTok, but only for like robotic stuff and really good robotic stuff, not like intro robotic stuff.
Yeah, and as a personal kind of thing, I can say that when I go to these kind of events, I always have like the best results going to these lightning talks. Like they don't, because they're so short and there's so many of them, like they don't get the same amount of like people that are doing the big talks, like talking to them and interested. So like if you go to these lightning talks, you'll probably see someone doing something that you're super into because there's so many of them and they kind of have to be pretty enthusiastic about it to even want to do this. And you're much more likely to like find someone that you can make something with at these kind of smaller events than in like trying to go up to talk to the person that did the keynote talk, right? So just, think about that.
Well, and we made it even more terrifying because we brought a gong this year. So if you went over your 2-minute time, like the MC Ryan would just like whack this gong. So the gong is like now the mascot. This is our team photo. You're talking about going to visit the whole team. We actually got the whole team in like a spot, like in one location for 24 hours. It's fantastic. And so the gong is.
What I'm looking at is a bunch of characters.
Oh, the T-shirts.
We see rats. Yes.
We see rats.
Oh, did I change the
screen? I used a team photo. I thought that, okay, the team has changed.
It worked perfectly. I assumed it was just dry humor.
Wait. Is this it?
Okay, now we can
Yes, we've got it.
I moved the screen so I'd be like looking at it directly versus looking off the side. I don't have a monitor, so I don't see what you guys are seeing.
Okay, good. We have a larger team. That's what I care about. Because 4 people, there was just 4 mice there. So
they're my war rats. They're great. Let's see. So what else do we got? So I actually did one. Like everyone knows that I'm like the ROS person doing work for Open Robotics. It turns out I also have like a second job. So I actually did a lightning talk did a quick lightning talk about my other side hustle. I'm going to sneak it in here, which is that I'm also on the board of the Open Source Hardware Association. We do stuff like open hardware definitions, open hardware certification. So like all those like single board computers or add-on boards that you're purchasing to build your robot or your computer vision system that are open hardware. We help certify them. We do policy advocacy. We're actually working on a big project. Phil, you're talking about buying masks. We have a big NSF project that's going on right now about doing open hardware for medical equipment, such that like all these masks, all these like medical devices that don't necessarily need like FDA approval, how can they all be open hardware and manufactured by anyone in case there's like, say, another pandemic? And then we also put on an open hardware summit where there's cool stuff. Like we have people talking about open hardware PLC controllers, open hardware like robot kits. We had a really great talk about an open hardware. It's a young lady actually from northern Michigan who's I think she's part of the Chippewa tribe, basically built this open hardware robot for doing basically native language education on reservations. So generally
Wow.
a very, very cool event. We're doing it again in Edinburgh, May 31st. Speaking of CFPs, the CFP is open. We're looking for workshops, volunteers, people to show up, sponsors, all of those things. All the information is on 2025.oshawa.org. If you're interested, that was my lightning talk. I probably did it faster on stage when you have 1,000 people looking at you. But that's a quick lightning talk. Anyway, more ROSCon talks. So we had, so one of the things you're going to end up doing if you're like a computer vision person working in robotics is you're going to end up dealing with ROSBag. So if you're not familiar with the ROSBag, it's basically the internal ROS format for data storage. So you have a robot running, it's got a bunch of LiDARs, it's got a bunch of cameras. You run it down the street, you want to save the data, you go ROS2 bag record, blah, 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 file name. And it basically shoves all your data into a file that you can replay and share later. So over the past year, we've done a ton of work to improve the performance of ROSBags. And part of that is like we've changed around. So there's, you can have like these component nodes now that basically allow you to use shared memory. So the movement of data across that boundary inside of ROS is a lot quicker. So that's really improved the overall performance of ROS bagging. We've also done a bunch of work or not me in particular, but like the community has done a bunch of work to do things like record ROS, not just ROS topics, but also ROS services inside of ROS bags. So you can see basically this function got called, and this function got called, and this data got collected, and then this data got collected. And it's all in this bag file. So this is a great ROS bag sort of talk, or a great talk if you want to learn about what's new and interesting inside of ROS bag. Really kind of boring topic, but ROS bags end up being the bread and butter of how you go from like raw data from a robot into like a data set that you're going to go train a model from. So understanding what's new and like what performance improvements or new features we've added in there is super helpful if you're kind of the data engineer putting all this stuff together. What else we have? Oh, I talked a little bit about this earlier. We had a ROSBag talk about Isorx 2. So I said earlier, right, ROS has all these different ROS middlewares, right? How do you move data either across a network or internally to your ROS system? Usually people use DDS. People are starting to use a technology called Xeno. People seem to forget that there is a third option for doing this, and it's a technology suite called Isorx. And so say you have a ROS system, and all it is like a bunch of cameras attached via like some sort of high-speed connection to a single computer, and all you want to do is ingest that data, process that data, and then save it or log it or do something with this. You're not really worried about network data transmission. You want to do it all in memory so it happens really fast. Basically, Isorx is the ROS middleware layer that allows you to do everything in memory versus moving across the network. So this is a sort of underrated talk. Isorx is kind of an underrated technology in my opinion, but there's some stats on basically performance and latency on ROS in using Iceworks to move your data around. So again, kind of boring stuff, not like super duper sexy computer vision research, but very, very practical hands-on tools that allow you to like have better performance overall in your ROS system or your computer vision application. In my old age, I've gotten much more interested in very boring but very useful stuff. I don't know, Satya, have you found the same?
Yeah, happens to all of us.
The boring stuff's getting more interesting as I get old. Let's see. Another talk that's worth checking out at ROSCon is we had a talk from about the Arduino Nicha boards. So these are the new Arduino boards that have basically an embedded camera on them. I think it's like, not quite sure what the stack is on the Nicha. I think it's like an embedded camera. I'm sure there's power and data of some sort. There might be Bluetooth or probably Wi-Fi. Anyway, you have like a postage stamp size.
One of those chips there looks like a Bluetooth or Wi-Fi. I can't tell which.
Yeah, but
Yeah,
you know,
the size
basically,
is very interesting. If you look at the tip of the fingers, right, that gives you a sense of size. Right?
Yeah, well, I think that's a daughter board there, but you know, the Nichas are postage stamp size, right? Super teeny tiny computer vision boards, and they're all open hardware, open software. And this team over, I think it's at IIT, which is the Italian Institute of Technology, is taking these little boards. They've basically built a ROS package, which means you can just install it really, really quickly, get these boards up and running, and use it for particular like robotics applications. In their case, they're putting them on the end effector of the robot, the gripper. So there's different ways to approach robotic gripping. Some people kind of think, oh, if I put a camera on the robot's gripper, the end effector, it might make doing robotic tests easier because then like I don't have to have a camera over here and sitting above the unit and then a camera on the hand itself. I just use the camera on the hand, use it for positioning and that kind of thing. But then really, what's cool about this is that
Guillermo del Toro. That makes me think of Pan's Labyrinth, right?
Oh, with the hand, with the eyes on the hand. Well, what I like about this is it's an open hardware, open software stack. Like, there's a ROS package for it, so you can just run it out of the box, and it's a fairly inexpensive dev board where you can get just some camera capabilities on your robot.
Right.
Let's see, what else we have? So this one is interesting. So this is a colleague from a startup here in San Francisco called Polym Robotics. And I love what they do. Basically what they do is I think their bread and butter, more or less, is taking like existing expensive vehicles like construction equipment, farm equipment, big trucks, that kind of thing. And they go in and they're the guys that will drop a couple of LiDARs on one of these devices, add a couple of cameras, maybe add a couple radars, and then add autonomy to them. So say like, I don't know, you're a mining operation, you have some big dump truck that you want to automate going from point A to point B. They're the people that'll come in, drop the sensors on there and make that happen. So this was an interesting talk from them about using radar for dynamic obstacle detection. So normally, like in robotics, you think like, oh, I'm going to do like dynamic obstacle detection with like vision or, maybe LiDAR. Turns out in a lot of ways, radar is the superior technology for figuring out dynamic obstacles. Like, it's kind of an analog. Like when I was working at Planet, we always talked about having synthetic aperture radar for imaging because radar works through clouds. Radar works through dust. Radar, it works in all these situations where you can't see stuff, and sometimes it really is a better technology, especially in these dull, dirty, dangerous environments. And so, quick talk. Alexander basically goes through and walks you through the process of adding dynamical object detection to like the ROS2 Nicha stack based on radar. That was super, super useful talk.
Yeah, as a just to give a little overview to people who may not be familiar with all the sensors, If you want good, vision sensors will work whenever you can see things. Radar will work even with bad weather, right? And then we have LiDAR, which is usually used for 3D mapping of stuff. You get a very large overview of your surrounding. And then you have ultrasonic sensors, which work very close proximity. So in very close, when you're close to things, let's say you're parking a car or things are very close, in those cases, ultrasonic sensors work the best. So that's, a rough lay of the land.
Yeah, and the thing is, I think a lot of the radar sensors are pretty cost effective too. Like they're used in the automobile. They've been used in the automobile industry for quite a while, and they're dirt cheap and very effective. So it's a nice like trade-off between quality and cost.
Right.
So then, I grabbed this ROSCon talk here because it's a stand-in. We had a whole session on like LLMs and AI in robotics. There were a bunch of different talks. There's a bunch of competing people who would like build like, here's how you integrate like an LLM within ROS. Here's how you add, this model into ROS. What I liked about this one is that it was a survey of other methods. It's a survey of all the ways people are basically integrating AI models into ROS and how to think about it architecturally, right? Because and it was an interesting talk. It talks a lot about like, here's your basic idea of a robot. Like you're going to have some software that talks to like, say, a microphone. You're going to have some software that talks to like a speaker. You're going to have something that, drives the wheels or the legs or, whatever the propulsion is for the robot. And, at the end of the day, I think very likely, there's people who think, oh, we just have this robot and you wire like the raw motor outputs to the model and the raw vision inputs, and you train the model and there will be no robot software in between. It'll just be this model. And in reality, I think much more likely, right, these things are going to be composed together out of realistic and sort of compact software modules that all interact. And so this is just a really interesting talk, I think, looking at how people have approached the problem and sort of, from a software engineering perspective, where do all the boxes set, right? Like, how if you're going to have, say, an LLM model helping you do robot path planning, how do you abstract that away? Like, how do you represent the obstacles that you may feed that LLM? How do you take its like commands that come out of it and feed it into the robot? How do you kind of throw an interrupt? Like this is it's sort of the meta discussion of all this AI discussion, of all the AI hype, right? Like, how do you actually, once you have some model that kind of works in the lab, how do you actually go out and put it into a real robot out in the world? And how, like, maybe do you abstract it such that it can go from multiple different kinds of robots?
It's almost funny to me when people discuss AGI, right? They are always discussing it in the context of LLMs as if that is it, right? It's
a foregone conclusion that that's what that'll be, right?
Like it's such a narrow thing when you consider AI. The things that we do with LLMs is such a narrow piece of the puzzle, right? When AI interacts with the real world, all the perception part, I mean, that's the big deal. That's, forget about AGI. Even for AI to be useful in the real world, right? Robotics is going to play such a big role. And people who are saying that, oh, we'll have AGI in 2 years, I don't even know what they mean by such things, right?
I don't even know if human intelligence exists, right? Like,
well, we are
the Twitter brain drain.
The two intelligences are approaching each other for sure. We are declining, and robots are.
Yeah, human intelligence going down, robot intelligence going up. Like, there we go. There's the singularity.
Well, my saucy hot take on this is I keep telling people I am short LLMs and long NERFs, right? Like, I think some of the like 3D, like the recognition and 3D reconstruction technologies where you can actually take a camera, spin it around a little bit in a room and have like a full 3D model and understand both the geometry and what's in there in terms of like perceptual understanding of the
Yep.
space you're moving through, huge.
Semantic knowledge of the stuff
fact,
in there as well.
Yeah.
Like, yeah.
In fact, in OpenCV, we have these side projects which they are not ready for prime time. We are experimenting with it. And one of them is spatial AI, where the idea is that, you take a bunch of pictures around the house. Let's say a house. I'm just picking a specific example, right? The outside of the house, let's say, right? And then you generate a Gaussian splat using that. And now you are in a position to just put a camera, right? If you put a camera anywhere in that outdoor space, the camera is able to locate itself, right? So that you don't have to do this very tedious calibration process, right? Especially when
being able to relocalize.
Yeah, the camera. So that I know I don't know how far this idea would go, but it has very good possibilities, right? So, I mean, those are all the various things that that are so exciting about AI and robotics and everything. But people, they keep focusing on this AGI, and when they talk about AGI, it is so narrowly defined. First of all, nobody has accurately defined it, but whenever they talk about it, they talk about it in the context of LLMs only, which just drives me nuts.
Yeah, I could go on about this for a long time. Like I'd like to see robotics has gone so far, but you're like, coming back to the rats that are on my screen here, right? Like I'm yet to see somebody build a robot with the sophistication of like a small mammal, right? Like we can barely do cockroach level behavior. Like, yeah, we're getting to the point where things can move around really well, but like, avoiding certain things dynamically and then also pursuing goal, like having a goal and actually achieving, like we're still pretty dicey on that. I'm like, yeah, I think we got a minute.
Right.
Yeah, I totally agree. I'm, like I said, I'm short LLMs and long nerves, and I think we still got a while. Oh, this you'll like this one. I don't know. Have you guys heard about this scenic?
I don't know.
So, okay, so this is a cool talk. And like, it's also a talk that sometimes proves me wrong. Like, I'm not very big on domain specific languages for programming. I tend to say, like, you had a problem, so you wrote a domain specific language. So now you have two problems. That's my sort of opinion on it. But like,
Yeah,
this
shout out to JWZ for the approximation.
Yeah, but like this one, I'm okay with. So, all right. So when you're training, when you are doing some of these, you're either like writing tests for your robot, or you're trying to build a synthetic data set to do some sort of deep learning with synthetic data. You might have you need a bunch of scenarios, right? So for example, say you're an engineer at Waymo, and you have a bunch of, like you have a four-way intersection, right? And there's so many different ways that you can approach a four-way intersection, right? You can go up to the four-way intersection and no one's in there.
I always go first.
Yeah. Yeah. You can roll.
Hey, just so long as everybody knows that's the rule. Satya goes first. Look to your left. If Satya's there, then he goes. Yeah.
Exactly. You could have the scenario where you roll up to the intersection and there's already three cars there and they're honking at each other. You can have the scenario where there's one car on your left. You can have the scenario where everyone's doing a California stop and they've all kind of stopped, but they're all still kind of moving and they're all going to crash. There's infinite numbers of scenarios just in this one case of a four-way stop in a vehicle. And so what this domain-specific language lets you do is basically build simulations that cover all of these, right? So like, if you think of it as like in software testing, right? You want to have an example of every possible case of something. This language will basically let you say, for this intersection, for all the various possibilities of cars rolling in and out at four different places and along the corner or something, generate a simulation that covers this scenario, and then run the robot through it and see what it does, which I think is just like, as a tool for testing and like building robust software, I think this is really cool. It's one of the few cases where I'm like, okay, this is kind of a domain-specific language that I think needs to exist. This has been around for a while, but what's interesting, right? This is simulation, so like,
right.
the take home here is like, say you want to train a model that recognizes, I don't know, stuff on a table, right? And you have like 100 different objects, like in like, 15 lines of code, this thing will generate you like all of the synthetic images that you would need to train that and build it. Which I think that's a super powerful tool for computer vision. Obviously, like training on synthetic data, like your mileage may vary. Who knows, like if it'll actually work? It'll probably kind of work depending on how good the simulation is.
Okay.
But it'll get you it'll get you 80% of the way there pretty quickly. So I think this is super handy.
Nice.
Yeah, so I guess, I mean, that's the short of it. There's a ton of other talks. I guess I should say ROSCon's going to be in Singapore next year. It'll probably be huge, probably be 50% bigger. We're figuring that out, probably be in October. And then we also still have like 3 more ROSCons coming up this year. And they're like back to back to back. We have one in Germany. We're going to have our first ever ROSCon in Shenzhen. And then the second annual ROSCon India is going to happen. And I think at the end of that week.
Where in India?
Bengaluru.
Okay. I can see. Okay.
Yeah.
And what's the time? Which
I want to say they don't have the dates on there. I want to say one's like December 11th, 12th, and 13th or something like ROSCon India's or ROSCon Germany's like the 11th and 12th, and then ROSCon China's like the 12th and the 13th. They're right back to back to back to back. And like we didn't plan it that way.
December 4 to 6, it says here for ROSCon India. December 4 to 6.
Yeah, and I don't know if these will be live streamed or not, but we usually, for all the regional ROSCons, we also put all the videos up on the ROSCon website as well. So they're all there. And let's see. Yeah, and like I said, if you saw something you like, you saw something you're interested in, they're all on roscon.ros.org. And I guess the last thing I can say is we are also a nonprofit organization, just like OpenCV. We'd love your support. We'd love you to join the OSRA Alliance as an individual or on the order of your company. And, you can also just donate to us. We're a nonprofit. It's Christmas time. I've been handing out all of the nonprofit donations this Christmas, like left and it's, we'd love to have it. And the open source stories really, really do need your support. As somebody who works for 2 of them, like they really could use individual support. People think we get all our money from, 1 or 2 big tech companies, and that's really not the case.
That's absolutely true.
So that's what I have. I mean, if you guys want to talk for a couple hours, I can go on about all new ROS stuff. But that's the ROSCon summary. I don't know. How do you guys temperature?
Let's take a break here. I mean, we're we're at time already. So let's do our trivia giveaway here. And then if people, we have a couple questions we can do after that, and I think we can call it a show. So go ahead and, Kat, do me a favor, unshare your screen there.
Yeah.
Yes, and Juan in the chat there saying, hopefully they can have a ROSCon in Latin America. That sounds like it would be pretty damn popular. There's a lot of stuff going on down there.
There's a bunch of people in Colombia and Argentina that are talking. And like part of my job is to poke people. I think we'll see a few other countries. I'm looking at you, Poland. I want the Polish ROSCon next year.
So I had spoken at Medellin, Colombia, PyCon. It's a beautiful, beautiful city.
I was talking to somebody from Medellin last week about this.
Never got to go to PyCon, even though I was basically a professional, Python software developer for like 10 years, and I never managed to go.
PyCon's the best.
I've heard so many good things. So folks, if you need a reminder or if this is your first time joining us, one of the things we do on this show is a giveaway to you in the audience. I am going to ask one trivia question based on the presentation from our illustrious guest, Katherine Scott, and the first person to answer that question in the Zoom chat, which you can get to by going to opencv.live in your web browser. I'll give you about 5 seconds to do that. The first person to answer correctly here in the chat will win the OpenCV course of their choosing. You can go to opencv.org/university to see what courses are on offer. So, if you have won in the last couple of months, please do not answer and give other people a chance to win. I'm looking at you, Partha, our trivia shark.
What happens if I answer?
What's that?
What happens if I answer?
Well, I mean, everybody loses then. That's, hey. So, this one's probably gonna be pretty easy. I'm gonna try to make it simple here. Um, we talked about ROSCon 2024 here, the big one, and it took place in a specific city and country. What are those?
Uh,
Both,
right.
both. Oh, looks like we got
Oh,
one. Kat, can you tell them what we were looking for there?
we're looking for Odense, Denmark.
That's correct. And the first person to answer that correctly in my screen here, remember you have to send it to
Norway. Oh, well,
everyone,
they make them
was
angry.
it looks like Matha
Yep.
Goram. Matha Goram was the first one there. Congratulations, Matha. Please send one email to phil@opencv.org with the course you would like. Once again, you can go to opencv.org/university, pick any one of those courses, send me one email, and we will make sure that you get it. Yeah, so we've got a couple of questions here. Let's do a quick one. This is kind of a more general Ross one that should be a should be a pretty easy answer. Um, Michael Bartosz would like to know, can ROS be installed or executed on any computer or CPU, MPU, whatever? Is there a good list of compatible hardware for ROS anywhere?
So let me preface this by saying there is can it and should it, right? Like I would encourage you to think of it this way. It is open source. It is a bunch of C++ and Python. You can do a lot of things with it. Should you as a beginner? Most likely not. So what we have is if you just type into Google ROS Rep 2000. So basically, every time we release a version of ROS, it says like this is what we build it on. Here's the things that we promise it'll work on. Here's the things that it'll most likely work on. Here's things that like people in the community get it to work on without problems. And then everything else, you're on your own. And so if you don't know what you're doing, you're going to have a bad time. And this is a thing that like we run into ROS fairly frequently. And I have to be very, very clear about this. If you are new to ROS, generally all of the core devs and where the most testing happens is like each version of ROS ships with a very particular version of Ubuntu. There's a couple other Linux variants it'll work on. Use those. Use them in a Docker container. Yes, you can get it to run on Windows. Yes, you can get it to run on Mac. But the people who do that are really good at what they do, and they're kind of ROS experts. Do it, do the simplest thing first. But you can get it to run on Raspberry Pi. You can get it to run on other embedded systems that run like Ubuntu and stuff like that. So generally, yes, but be careful. It doesn't mean it's going to be easy all the time.
Yes, and this is much the same with OpenCV.
Exactly. I'm sure you guys feel this pain too.
Yes.
Right.
Yes, definitely. So yeah, we got a couple more here. In fact, our trivia winner here, Martha would like to know, do you have any recommendations for four-wheeled robots supporting ROS 2 in the sub $500 range? Assuming they already have a host machine in mind, like a Raspberry Pi or a Jetson or something.
Under $500? I don't know. So it depends on the wheel configuration, right? Because just like Ackerman steering and like that kind of thing. One thing you might want to look at is, so we have there's the F-110, which is the scaled down little, basically they're RC cars. They're autonomous RC cars. I don't even know, $500 is a real low price point in a lot of ways for robotics. I think your best bet is to go look at some of that sort of stuff, because there's a huge, you're basically leveraging the RC car market. So components are cheap. There's a huge community there. They'll walk you through a lot of it. That might be a good place to look. The cars are racing. They're overtaking each other. If you're going to ICRA or IROS this year, there's usually a race, usually worth checking out. So you'll find a lot of people that also can help you build something too. So I think that would probably be my recommendation.
Great answer. And one of my favorite things is where like these, I don't think a lot of people don't necessarily realize how old the hobbyist space is for like tiny robotics and like RC cars and stuff. People have been doing this like and having their own newsletters and meetups for like 100 years. Like it's crazy. It's just like model train people, you know, like there's folks that are just have been seriously into it for decades already. And so there's a ton of knowledge, and they're usually just so happy to that someone else is interested in this stuff that they'll tell you everything. You know, it's usually a pretty good experience. Some folks in the chat say the Scuttle robot is around $500. Maybe go check that one out. Can't say myself. I've not tried it out.
I don't know anything. I don't think I've ever heard of this robot.
I like the name. Scuttling is fun. Scuttle's a fun name. It makes me think of Dr. Zoidberg from Futurama. Salim Sadman in the Zoom chat would like to know. We've kind of beat around the bush on this the last two questions. Kat, how should people start their journey with ROS? What's the best getting started places for folks, regardless of maybe their skill level with software engineering or robotics hardware? Where should they start?
Well, so that's a hard question, right? Like, because there are places where you can come in with nothing and do really well, right? Like a first robotics program where your people are going to gently introduce you to all the topics. You can be a software, like if you're already a decent software engineer, learning robotics is a lot less difficult. Or like if you're a mechanical engineer that can kind of code, you want to like it kind of depends on where you're coming from and where your skills are already there. I mean, part of that first workshop that I showed you, the one I wrote, we sell the well, we sell it. We don't really sell it. We create the turtle bot, right? That's kind of our recommended platform for people getting started. And like, I'm not saying that to sell robots, because like the Docker container that contains the simulation is free. And what I like about that is that it contains all of the stuff. It's a working robot that you can take apart and tweak and understand how it works. Because one of the anti-patterns I see is that like I see students that barely can code, don't understand electrical engineering, don't understand mechanical engineering, and they're like, I want to build a robot from scratch, and they just take on way too much at once, and they get overwhelmed and frustrated, and then they like flame out. And so like I tend to recommend like understand the set of skills that need to build on to get to where you're going. And so like I want to be a roboticist. Well, maybe start by learning just like how to write some Python with an eye to like, oh, I'm gonna write Python to go build a simulation or like a 3D model. So I know like, oh, I understand how things move in 3D and I understand coding, and then like fold in like, oh, I bought an Arduino. I understand how to like roughly how to wire stuff up, DC stuff up to make it work. Do things slowly like that. Don't try to bite off too much at once. Like a lot of people who at least went to school for this stuff do it over 5 years or 7 years or something. So don't think that you have to do it all at once. A very dangerous pattern.
Yeah, it's that's definitely true. I mean, I think most people when they start out go through something similar to this, right? Where a lot of people probably you don't know what you don't know, and so you bite off more than you can chew. It's like watching a kid. You hand a baby an entire banana. That whole thing is going in their face, right? Like they're not going to take a bite of that banana. It's going to go. And that's kind of what, I think what a lot of early career people tend to do. Not that there's anything wrong with that. You actually do learn a lot about what you like to do, what you absolutely hate to do, like what you don't want to do again. Failure is almost always useful. I'm living proof of this. But the way you get to that failure also matters. And it's really important to be honest with yourself about how much time you have, what your skill level is in these various things, and what you actually do know, because then you can easily find out what you don't know by repeatedly failing. I think that's about all of our questions here. You got Kat, if people want to find you online and follow you around the internet, what's the best way for them to do that?
For me, it's just KScottZ on all the platforms. Open Robotics is just openrobotics.org on Twitter. We've got a LinkedIn. Generally recommend you go. Oh, yeah, I was going to say I have a slide for this. I should have done it. Generally, there's if you go to, I put all of the important ROS stuff in the ROS2 GitHub repository, like at the front of the page. So if you go to like github.org/ROS2, just that. Don't go to the code. There will be a page that'll show you where our Discord is, show us where our discourse is, show you where all the ROS source code is, tell you about all the ROS events coming on, all those sorts of things. So.
Cool. Yeah, we'll definitely drop that in the show notes here for folks. As always, folks, if you missed the beginning of the show or you want to review this, you can find it on our YouTube channel at youtube.com/@OpenCV official. Is it official OpenCV? I'm second guessing myself now. Yeah, it's open at OpenCV official. Satya, you want I'm telling you what. Satya, you want to take us home?
Yeah, thank you, everybody. Thank you, Phil, and thank you, Kat, for this amazing presentation. I'm definitely going to check out some of the talks that you mentioned. And thanks our audience for showing up every week. Thank you.
Thanks, Phil.
Yes. Yeah. Thanks so much, everybody. Take care of yourselves out there. Take care of somebody else if you can. We will not be back next week. We're off for U.S. Thanksgiving, so we'll be back in 2 weeks with a presentation from our buddy Raymond Lowe from Intel. In fact, stay tuned for that one because we have a very special giveaway planned, a little fancier than our normal OpenCV courses giveaway. So watch your emails, subscribe to the OpenCV newsletter, and have a great day wherever you may be.
Thank you.
Thanks, Phil. Bye.